Hello and welcome to this video in the measurement series, this time all around the volume of cylinders and spheres. All about volume of cylinders and spheres. So the volume of cylinders works just like other prisms being those right prisms, the type of prisms that have a face that then follows through down the shape. That is exactly what we have here. So it's like a cross section. That's what we need for these types of problems. So this is the cylinder here. Again, we have V equals AH. V equals AH, and in terms of a cylinder, we have that circle. So we're using pi r squared and then multiplying that by the height of the cylinder. So all in all, our formula becomes pi r squared h. So fairly simple and straightforward use of a formula here. Let's have a quick look at the example we have. The first example we have here. We have a cylinder with a radius of 8 millimeters and a height of 12 millimeters. So they're the only bits of information we need to find the answer to this problem, which we're going to do to 2 decimal places this time. So let's set up our formula. It's always a pretty good spot to start is that formula. So V equals AH. And as we said in the formula above, we've got that circle around the front. We've got this circular bit here. And then we have the height part here. Alright, so there's our area. And then over here is our height. Okay, so in terms of that formula, we're going to use that circular formula. So that's pi r squared times h. And that's all we need to do to get started. Now all we have to do is substitute in. So we've got pi. Pi is just its own number, so it gets to stay. Times r, so the radius is 8 millimeters, so it's 8 squared. Times the height of 12, that's that one there, and then we calculate that out. So you can just type that straight into your calculator and you'll get a nice long decimal because we're using pi and pi does not finish. And it just keeps going and going and going and going, but we only want 2 decimal places. We only want 2 decimal places, so we have 2, 4, 1, 2 point. Now if we want to go to those 2 decimal places, I'm going to go to here, I'm going to cut it off, and I'm going to look at this number. So while looking at this number, I'm going to say, is it above 5? 5 or above? So I'm going to ask myself, is it 5 or above? Is it 4 or below? So if it is 4 or below, it stays the same. And if it's 5 or above, it changes by going up 1. Now we can see here it's a 3. 3 is below 4 or 4 or below. So we can just leave that as 7, 4. Now we need to put in our cubic units. We have millimeters here, so it is millimeters cubed. And that's that first problem done. Let's move on to the second problem. This second problem is all about a stack of DVDs, or a single DVD rather. So DVDs still available, which is excellent. I like my DVD collection, and understanding how much space they take up can help plan how you do your home libraries and things like that. So we have a diameter of a DVD. Now we don't have a diagram for this one, so let's quickly make one up. We have a circle. Alright, so that's the outside of my DVD, and then I have another little circle in here. That's that center hole of the DVD. Now the diameter of this hole has been given to us as 1.5 centimeters. So we want the radius instead though we want the radius. So what will the radius be? The radius is half of 1.5, so therefore the radius is 0.75 centimeters. That is the radius of the hole in the middle of the DVD. We've been given the radius of the whole DVD, or the diameter of the whole DVD, as 12 centimeters. That's this piece of information here. Okay, so the diameter is 12 centimeters. We don't want the diameter, we want that radius again, which is half, so that is 6 centimeters. Okay, so this one, we're not really using a circle as such this time. This one's actually the annulus. Shape. That's that ring shape that we've spoken about in previous videos. That ring shape. So the formula for this one, for that face, that cross section, is as such as shown there in that ugly orange color. So we need to use that as part of our working for this question. So volume equals the area times the height. Okay, now the height for this one is the thickness of our DVD, which is 0.12 centimeters. Let's fill in what we need. So we need that area. So that area is that pi, big radius squared minus the little radius squared, all multiplied by h. So we have our pi. The big radius was 6 centimeters. That little radius 0.7 centimeters, all times 0.12. Now, again, because our calculators are pretty special things, you can just type that straight in. You don't need to do any other working out. And we're going to get a long, because we're using pi, a nice long decimal again. And it just keeps going, but we also want that 2 decimal places again. So let's cut it off at the second decimal place. All right, is it 5 or above? Is it 4 or below? They are our 2 questions that we need to ask about the number next to the in that next decimal place. All right, so that's this number here. That number there is a 9, so that is obviously in the 5 or above category. Therefore, we have 36 or 36 in our decimal section there, because that 5 does need to go up by 1. Now, the reason we're using 5 or above and 4 and below is because 5 is around about that halfway mark in terms of our decimals. So that halfway mark is getting closer to the bigger number than it is to back down to the other. So that's why we're using that. You'll see other types of rounding come into play, particularly when we're looking at things like degrees. Now, the only thing missing from my answer here is, whoops, my centimeters cubed. I'll just reset my screen here. Okay, so that is the cylinder. Now, we're going to move on to the sphere. The sphere is a little bit different. Because it doesn't actually have that cross section. Okay, so a sphere is not a prism. In the same fashion as a cylinder, it doesn't have that cross section that we need to be able to do the area of the face times the height. So we're going to do something slightly different with the sphere and the hemisphere, and that is using these formulas right here. Okay, so the sphere, obviously, it is a whole bunch of those circular faces all bunched around, and that gives us 4/3 pi r cubed. Cubed obviously being because it is a 3-dimensional shape. And the hemisphere, well, that is a half of that 4/3 pi r cubed, which is 2/3 pi r cubed. Let's get stuck into the questions for this one. Find the volume of these solids to 1 decimal place. So here we go, 1 decimal place is what we're looking for. We have a radius and we have a diameter. So that is a radius, so we don't need to do any extra there. This one's the diameter, so we will have to think about this one a little bit more. Let's do that first one. So volume equals 4/3 pi r cubed. So 4/3 times pi, and we have the radius already, which is 7, and it's got to be cubed. So we type that into our calculator. We get 1436.755. That should have been a 0. Sorry about that. 0.4 and on and on and on. We want 1 decimal place. So looking at that, 7 is in that 5 or above category, the over halfway category. So 1436.8, and this one's meters cubed. So next, that's the 1 decimal place. Okay, so there we have that formula that we've started with. We've substituted in. We've understood that this sphere is not a prism in terms of it does not have that cross section, so we can't do it the same way as other questions. Same with our hemisphere. V equals 2/3 this time pi r cubed, simply because that hemisphere is a half of the sphere. If this full sphere is 4/3, then half the sphere is only 2/3. Okay, so 4/3 for the whole sphere and 2/3 for the half sphere, right? So we've just halved that sphere to get to it. So we know as well that the diameter is 3.5 meters. We actually want the radius. So the radius is 3.5 divided by 2. 3.5 divided by 2 is 1.75. Nice and easy there. So just making sure that we are using that radius and not that diameter, because we won't be able to get the same response. So back to our formula here. 2/3 times pi times 1.75 cubed. Okay, so that's all of that 1.75 cubed, and we're going to end up with 11.2246 on and on. I want 1 decimal place, so I go to that first decimal place and I cut it off. I ask my 2 questions. That next number is a 2. That's in the 4 or below category. So we're going to have 11.2, and again this is in meters cubed. Okay, now you would be well within your rights for all of these questions, because we've rounded, is if we get rid of that equal sign and we use the approximately equal sign, which is this squiggly equal sign. Okay, so that would be quite well within your rights, and in fact that would be encouraged if you are not doing an exact answer to use that approximately equal sign. Okay, so that's all the examples for this particular video. Hopefully that has helped you work with this particular problem, and I'll see you in the next video.